Hello. The previous video I left a cliffhanger with the implementation of stickiness info in the level data to to share between the generator and the game, and we are doing that. Let me check. I have an idea of an optimization for this feature. Let me see. Yeah, the sticky directions I was storing as a list of points, but I think I will revert to the old idea, but without using the bit fields because they are a bit cumbersome. So we will have four booleans, one for each direction, because this is not only an optimization but also a simplification of the serialization of the data, because at least I hope so. Let's define. No, I will use manual bit field manipulation and const I think I can write it this way. Let me check. No. Make no property. This is right. Up and down. And let's store different bits in sticky info. Sticky size. Okay, 462. Okay. Here I will, instead of doing this, I will make it a bit more I will make it a bit more manual. Right, up and down, and let me check. Sticky size is suppose yeah, this is automatically initialized to 0, and I'm adding these bits. Okay, let me and 6 to 1. Okay, this I will make an auxiliary function. first stack. I have the direction. Yeah, this will be a bit of a chore, but it will simplify another thing, and it will make it faster, so it's worth it. I will make the I can borrow the old code. I copy. Okay. Why is this sticks to? I must check. I think the language treats non-zero values as true, but to be sure, to be safe, stick to right, stick to up, and stick to down. Okay. Then, instead of this condition, and instead of this one, okay, this should be equivalent. Punto is point. Because I translated some of the Spanish. Okay, here multi-search. Let's remove all the level data. Okay. And let's do a search on new levels. Okay. Here the problem is that we are not encoding yet the information, and all our boxes are O characters, and that is precisely the cliffhanger from last session, because we need to encode in some way in each character the sticky information, or the stickiness information that is sticky. Okay, so the function that serializes the levels is this one, and here we are adding to the serialization the character O. This should be a character, but okay, it's a string. Let me remove this. Let me remove this from the loop and move the condition to be the first one. And here, instead of adding a no, we must check the different directions. Okay, we have an integer in the struct, a small integer, that is this one. We cannot use it as it is, because this is binary information, and we must convert it into a character, a readable character. We could use Unicode symbols, but for example, this kind of symbols to represent which sides of the box are sticky, but I doubt very much that it would be easy to encode and decode this. This is a mess. Now, we will use a simple dictionary, or let's use const. We could use a simple string. We need 16 characters. Okay, 16. Or we could use hexadecimal values. Yeah. And we could index sticky size. So this byte will contain values from 0 to 15, because the box, a box with all the sides sticky, will have a value of 15. And this has 16 characters. Yeah. This should work. So let's remove the data and search some levels. Let's see. Here the boxes are 0, A, 1, 2, 0, 2, 1, A. We have a problem in the logic of the game that I will solve later, because the generator uses another internal representation for hashing that depends on the order of the boxes, because we are sorting the boxes according to the position to avoid repetitive states, but this this will be a problem because now the boxes are differentiated not only by their position, but also by the stickiness, their sticky sides. So this sorting will not work. We must make a custom sorting. Let me return to the console. Yeah, we must make an opcomp function. This is opcomp is a const, and we must compare if if the positions are equal. We must compare the sticky size. We have a typo. Sticky size. Sticky. Okay. We must compare the sticky size, and if not, I think this is correct. What? Ah, sorry. Wow. Template instance. Const. I was opcomp. Here I use a reference. Why? The autocomplete was a bit. What happens now? The constness is a problem. Okay. Now we are sorting properly the boxes. It's a bit slower than before. Let's see the data now. 73E11. 73E11. 1 is to the left. But other, okay. Yeah, obviously this is less readable for debugging purposes. I could use another more complex representation, but for now it will be sufficient. Okay, now we are saving the thickness information. F is sticky in all sides. D is sticky let me see, 15, 14, 13. Yeah, it's not very translatable in the head, but for now it will be useful. I could add auxiliary boards below this one to show the stickiness, but I don't know. For now, it will be enough, I think, for a video. I will leave the cliffhanger of how to parse this information in the game, because if I export now the level information into the game, now the game is not reading any boxes and all kind of errors will appear. So obviously this is not, the game is not reading the boxes properly. So next video perhaps I will modify this function, perhaps make it a bit more elegant, because this is the part where I need to instantiate the prefab for the crates and setting the stickiness. This will be commented because now this function is no longer useful. And now let's make a to-do. To here, let's modify this is done, but now we need another task. Okay, for now it's a good video, I think. Let me know in the comments if I'm too slow or too unclear in my explanations, or if you have ideas for further optimizations or features, etc. Thanks for watching. Bye.